My name's Joris Peels, and this is another edition of 3D Printing News Unpeeled, thanks to 3dprint.com. And today we have some news of a kind of like artificial muscle kind of a system. This is one of there's a bunch of teams worldwide trying to work on, kind of like elastomeric or soft actuators. And this has been a challenge for a lot of people. And there's another team that thinks to have a really good kind of programmable stiffness, kind of soft actuator that uses silicone and carbon fiber. And it's essentially a programmable carbon fiber type of muscle or soft actuator. Now, the thing is, soft robotics is said to be a really exciting area. There's not a lot of applications, but there's a lot of excitement about like a completely different family of robots that work very, very differently. One of the things is, how do you get these things to grip things? How do you get these things to move, walk, do their thing? Usually you have kind of really unwieldy kind of systems with kind of like pumps and balloons that inflate and deflate and all these. And these are really bulky, difficult to make. They have a lot of parts and they're really clunky, and they're really make for really bad soft robots essentially. So what these guys have done is they've basically done this silicone and carbon fiber combined kind of programmable muscle, and they then had a reinforcement learning algorithm, an AI algorithm, to control the stiffness of the muscle. The hope makes the overall muscle have less vibration, or be less responsive to vibration, more resilient, and be able to do its thing without interference from vibration. And generally, it's going to be a lot less bulky. This is available as an open access paper, which is very laudable and nice. It's an advanced materials technology, and it's called 3D Printed Phase Change Artificial Muscles with Autonomous Vibration Control. The paper is by Muslim Mohammed Abbas, Kuzani, Mahdi Bogdani, Yongxiang, and Ali Zolfgarian. I think this is exciting work. We don't really know what soft robotics will do. Is it going to be safer robots? Is it going to be super low cost robots? Is it going to be a completely different way of envisioning robots, or are they going to have really specific cases? One of these things is always like a kind of the cusp of, becoming better and better without us really understanding what it's going to do in our daily lives. So that's been a problem, but also it's one of the most exciting things about soft robotics, and the intersection between soft robotics and 3D printing is huge, because we're the best technology in making a lot of these things often. So the next thing is news that A-Metal, which is a company called A-Metal, it's a Zurich-based, Swiss-based company. They got 150,000 Swiss francs from something called Venture Kick to help produce their small, powder bed fusion 3D printer. They've got a cartridge-based system for better powder handling, which they hope will lead to a safer system, and also lead it to being deployed without all these complicated safety measures and masks and things that you have to wear. And they're targeting small to medium businesses. They really want a low-cost 3D printer that is going to be accessible metal to small to medium businesses and let them on the shop floor print parts. Now, this is a wonderful development we're seeing lately. We've been seeing a lot of work on the top end with 12 laser systems and multi-million-dollar systems being used by the Army and the Navy and the Air Force, and missiles and satellites and new space companies. But also on the bottom end, there's a lot going on, actually. There's Kurtz Airsa and One Click Metal making very similar systems to A-Metal, I think. These kind of systems that are kind of like more plug and play, less operator training, more safety, and incredibly low cost in the case of the Kurtz Airsa system and the One Click Metal system. We're talking like 120K or something like that. And also, like, there's a lot less cost in having to make sure that your HVAC and all your safety equipment's up to scratch. So another one of these, another competitor, would be very, very laudable, very, very wonderful. Now, of course, 150,000 Swiss francs is not a lot of money when developing a laser-based metal system, but it's wonderful to see you guys make progress. And I think there's a lot of precision industry, a lot of industry in Switzerland. There could be a lot of interest from investors in this kind of thing, and I think that this is a wonderful development. And should be lauded, and I hope they make it to market with something that wows us all. The next thing is something that has been going on for a long time, but ESA, the European Space Agency, is now talking about it. It is 3D printing electromagnetic coils. These are, well, okay, usually this is, these kind of things are hand wound on a wire, or they're made out of a whole bunch of brazings or different constituent parts after be put together. There's companies like Additive Drives that are in these kind of winding coils and these kind of things, and developing things like this for lots of applications. ASA decided to try to do this for space as well. So they did a project called Atomic, the additive manufactured metal coils, and they're looking at using green lasers to manufacture 99% or so pure copper, using laser powder bed fusion. If we look at the green laser thing, and then the build platform, I'm thinking that they're using a Trump machine, but it could be something else, Sysma, or I don't know what it could be, but probably a Trump machine, I would guess. And the idea is to use pure copper, in this way to make a highly functional electromagnetic coil. They use topology optimization generally to look at how to reduce masses. Of course, in a space kind of application is always really important. And just the overall performance of the coil was increased. The magnetic performance of the coil was increased as well, which is very laudable on top of that. They got a relative density in final part of 99.99% and electrical and very high electrical conductivity as well. They think that this could be used for a lot of applications, including low vibration magnetic bearings and other types of systems, for example, for managing low aperture kind of solutions and stuff like that. So this could be something that they could use very extensively. So I think it's a wonderful development, and wonderful for them to publish this and tell us all about it. And I think this is something we're going to see a lot of in new space, but also traditional space. Additive manufactured, highly optimized components that really outperform what we see already. And there's windings and brazings and all these kind of like really automated, sometimes, or even maybe very manual processes that are very cost intensive, are really ripe to be disrupted by 3D printing. And space is, of course, the place where the business case makes sense very, very quickly, because the mass reduction we can do, and the types of labor. If you save labor in the component, and that can also make a big difference for these guys. So, but that doesn't mean that this will stop there. It could really very well make its way on a lot of other things that move. And it could make this way into very, very common applications as time goes on. So this is another version of 3D Printing News Unpeeled. My name is Joris Peels, and I hope you enjoyed this and found this useful, and you have a really, really great day.